Just a minute. Is voice clear? Comment fast. Voice is clear? Today no rain so far. Clear? Okay. One small information, not for general public, not for BSK batch also. Last class what question we solved? A simple support beam with UDL over the entire span and 2-point load. We found slope and deflection at all the points, and lastly also maximum slope and maximum deflection. Remember, in software ETAB, in the ETAB batch, I have given a message for them. Others not applicable. I will take up the same model there in the ETAB to create the model and check the answer. I think some of you already done it. You got the answer correct? Yes. No, some of you already tried it in the software. You got the answer because somebody sent me the link, sent me the screenshot. Did you get the answer in software? No, did you get? I think one or two, they sent me the screenshot, got some little, no, I will explain that one. Okay. Little difference will come. So, this is for ETAB and safe batch. All of them. Today's class, I told them, you correctly observe only first part. That is, see, I wrote the result here. All the result I wrote here. I noted down. Before rubbing the board, I noted the result. In the software, how this comes? Because in the RCC design, you are designed for bending moment and shear force, and if required for torsion, and then that is called strength aspect. Then we got serviceability aspect. Usually we check for deflection by L/D ratio, but some special cases, especially when deflection is very severe, it is advisable to go for actual deflection calculation. So, in case you want to find deflection, you can use software. One thing, here I told material is steel, there material is RCC. So, there you give material property RCC, and run the program there. And this question, when you do in the next class, ETAP class, I will tell this is steel material, and then cross section is given for you here. I will tell the cross section at that time, or I may tell now cross section. Make a note. How to create that cross section in the ETAP class I will tell. It is not rectangular section. Material is steel, or in the ETAP class, how to prepare the model. See, you know in ETAP class, how to find SF and BM and how to draw SFD BMD. Below that one, that is V2 and M3. Below that, you can see elastic curve also. That elastic curve here. And remember, I will explain later. Deflection here is in the direction of global Z. See, all the deflections are in the direction of global Z. And all the theta, rotation, when rotation comes, it is always about global. Tell which one? All these deflections are in ETAP global Z. And anybody can tell? All the theta, rotation, that is about global. Which one? Global Y. That is about global Y. Yes, remember. That you should remember at that time. Okay, start. That's all. Now, but Y max ETAP is giving at center. No. I will tell it. See, central deflection is 25 point not, how much? 26.226. Y max is 26.24. 0.02 millimeter, it cannot make out. Does it matter? When you check for deflection control, that 0.02 millimeter, does it matter? Tell me. Does it matter? 0.02 millimeter. Anybody will bother about that 0.02? No. So that we cannot do anything. But in the BSK class or in the basic class, exact calculation. Okay, now, what I will do is, I will tell the question once again. See, this is for general people or general public or BSK batch already solved. There is a simply supported beam, but for people in the ETAP batch, they should make a note from the class. They should prepare the model, because why? How to prepare the model known for them. They should prepare the model and get SFD BMD. Deformations I will explain in the ETAP class. A simply support beam is of span 12 meter. It is loaded by an UDL of 40 kilonewton per meter over the entire span. Then I will call this as A, this is B. And point load of 360 kilonewton at 3 meter from left end, and another point load of 180 kilonewton at 5 meter from right end. Then E for it is a steel. E equal to 2 into 10 to the power 5 or 200 10 to the power 3 Newton per mm square, and cross section of the beam is symmetrical I section. If I remember correctly, I will tell you now. Flange 400 and thickness of web is 12. Thickness of flange is 32 and depth of web is 800, because I designed it. Before giving section, I remember, because I designed it. Correct now, this section. This is the cross section, all in millimeter. Correct? Tell me. 360 at 3 meter. Yes, 3 meter I wrote. 360 at 3 meter, 180 at 5 meter, correct? Yes. Now, for you also, now the question is, correctly draw SFD and BMD. Remember, I am not explaining neither in this batch nor in ETAP batch. Why? SFD BMD over. Or those who are anybody new, general public, difficulty means go through my SFD BMD course. So that I am not explaining. SFD BMD. Then draw elastic curve, indicate all the important deformations. And then for the software batch, check the value by ETAPs. Okay, that's the question. So those who are in the software, this class you go through only till when I change the part. See, next I will tell you, now I will go for UDL, partial UDL. At that time, you can leave. If you do not want, If you want, but you can't, if you directly come today's class only, if you have not gone through earlier class, you won't understand. Leave it then. But if you are following everything, continue the class. So this class, when I finish elastic curve, that requirement for a software batch is over. Okay, now, first see what to do. I will draw the beam neatly here. See, I will draw the beam here. Somewhere here, I will draw the beam. I will use double line to understand. See, this is the beam. Okay, there is support here, support here. UDL of 40 kilonewton per meter. 3 meter, total 6 meter is there. This is, okay, 3 meter point load of how much? 360 kilonewton. Let's put it upper side. 360 kilonewton. And at 5 meter, okay, here. At 5 meter from there, point load of 180 kilonewton. UDL of 40 kilonewton per meter. Tell me, board fully visible? A, B, this I will call C, this I will call D. And then there is a reaction here VA, reaction here VB. If you do by software, you don't have to find reaction. Software will do it. VA is 585 kilonewton. This you get in the software. VB equal to 435 kilonewton. Okay, now, see, this is the beam. This is 3 meter, this is 5 meter, this is 4 meter. Over. Now, correctly draw SFD and BMD. First, silently I will draw without giving any hint. Baseline for SFD. No hint, nothing. SFD, all values are in kilonewton. Our sign is left up, right down, positive. In the E tab, reverse comes. Why? I told in the class. Okay, now, where is it? Okay. I am not seeing chat box also. I will draw SFD. 585. 585 minus 40 into 3 is 465 when you reach here. 465. Then down 360. 105 here. Okay. 105. When you reach here, minus 40 into 4. 55, small value. See, it will cross the baseline here. Okay, out of scale. This is 55. Then down by 180. Sorry, no explanation. 235 here. Again down by 200, 40 into 5. 435 here. Here, 435, it will come this way. This is the shear force diagram. Those who correctly, this is positive, negative here. Now, shear force diagram, there is a point where SFD crosses baseline. See, this is A, this is B, this is C, this is D. This I won't call E because I called E as center. So I will call this point as F. F is an unknown point. So I will do one thing now. It is an unknown point. I will first locate that F point. See, that F point, locate from here to here and from here to here. How? Somehow locate it. 105. Okay. It is 2.625 meter. F. From there, minus 4. 1.375 meter. Okay. And the center also comes here. For deflection calculation, center is at 6 meter here. 3 plus 4 is 7. 3 plus 2.25, 3 plus 2.625, 5.625. The center of the beam is somewhere here. That center is here. That is E. E is, it comes slightly after F. Center. Okay, that is center. Over. Now, draw bending moment diagram. BMD draw on tension side. Because why? See, actually, everywhere BM will come sagging. Sagging means tension is below the baseline. In the general class, I draw BMD. Positive means upper side. But here, it is BMD on tension side. Those who came to my SFDB, those who are going to SFDB class, they'll understand. Or those who are BSK batch, they understand. General public, if they don't understand, it is their problem. Because this chapter is slope and deflection. Okay, start. Here BM 0, then BM at C, show the calculation yourself only. It will come 585 into 3 minus 40 into 3 into 1.5. 1575 is the bending moment here. See, 1575 is the bending moment here. BM at D, this is the point C. Next standard point is D. D bending moment is 435 into 5 minus 40 into 5 into 2.5. 1675, little more. See, 1575, 1675. Okay, now, also you need BM at E. That is the point where BM at F, where shear post diagram is crossing the baseline. It will count slightly more. I think I told you yesterday answer. 17 something. 585 into 5.625 minus 40 into 5.625 square divided by 2 minus 360 into 2.625. 1712, little more, see, 1712.8125. Now, this is parabolic here, this is also parabolic here. Now, this will go further this way with the peak value and come back, and so many things are there. See, this is little more steep. These all I won't discuss here. This is little flat. This is different curves. These all I won't waste time now. In the E tab, this BMD will come, this SFD reverse will come. Did you get it? In the E tab, same SFD reverse will come, upper one lower side, lower upper side, and same BMD comes there. Tell yes or no. Those who are done by software, yes or no. Fast. I am not seeing earlier. Those who are done by software, did you get same SFD BMD? Fast. Say, same SFD BMD. Did you get it? Old comment I can't say. That's old yes. You tell yes first. When you made model by software, did you get same answer? Fast. Board not visible. Where? Board is not visible. Board is fully visible. Board not visible. I got a comment, board not visible, but fully visible I think. See there? Board is fully visible I think. I can see fully. At top not visible. No. Fully visible. Where? I can see the full board in the display. Not visible. Fully visible. Yes. Because I am seeing here. Still little more space is there. There is still little more space. I can see little portion above the board also. Okay. Now, draw the elastic curve. Remember, this parabola turning this way sometime. If there is no load, BMD will be straight. Remember, all those things are for bending moment diagram. Linear variation, parabolic variation. But remember, elastic curve is always curvature. You will never get straight line. So now below, 1712, okay, 1765. Below I will project and put elastic curve. Okay. Elastic curve, see. This is the original line, dotted line. This is elastic curve. Elastic curve, and right here, all, to save the time, all vertical displacements which are called, that is called deflection, is in millimeter. Software it may give in meter or millimeter. If the meter, convert it. And all rotation or slope here will be in degrees. But software will not give degree, it will give radians. You convert it. I wrote in degrees. Okay, now, see, first of all, when you draw elastic curve, these are all the answer we got. See, maximum deflection comes at 5.84365 meter from here. 5.84365 means I use a red color for that point. See, that maximum deflection point, I use red color. See, red color there. I use red color for that one, for maximum deflection. So, I locate that point. Where is it? See, that point is after F but before D. See, from A to F is 5.625. A to D is 7 meter. Maximum deflection is at 5.84365 from here or 6.15 from that side. So, it will be here. This is, I will put here now. See the center, somewhere little this side. Center is where? This is F. Center is, this is D. D is 7. Center is somewhere here. See, it is little this side of center, but after the point F, here, see. Or it is somewhere here. This is the point of the dot. Remember, the dot, I will give a new name for that one. A, B, C, D, E, F over. I will call the point as G. See, that G is point where Y is maximum. So, that point lies little this, when you compare to point F, slightly right of F, but before D, here, see. This is the point G. So, there deflection is maximum. So, why do you think? When I draw elastic curve here, see here, elastic curve, this is the point G. Maximum deflection. Elastic curve will come. Smooth curve. Actually, okay, here space problem is there. I have to bend and write, 1 minute. I have to slightly bend and write. Little out of scale. See, it is, what happened is, scale is complete. For scale is completely lost here. What to do? F point is, see, D is here, 5 meter. This is center. Center has gone slightly that side. Out of scale. Okay, manage. Out of scale. This is the maximum. Out of scale. Now I can't change anything. See, I should have put that one somewhat to scale. Okay. Scale, don't bother. Elastic curve will come this way. See now. This is the, and at the point where Y is maximum, your theta equal to 0. Theta at G. This maximum deflection is how much? 26.2477. See, this maximum deflection, I use red color. This Y max is 24.2477 millimeter. Okay, now see here, deflection at C. This is deflection at C. This is the point D, out of scale. This is center. Center is F. The center is E. Where is E? E is somewhere here, E, center. E is here. At the point E, center here, see, center. Deflection at C is somewhere there, 19 point, I'll write here only, see. Okay, I'll write here, 19 point, what is the answer? 19.3251 millimeter. Deflection at D is little more. See there, deflection at D is 25.096 millimeter. And deflection at E, center is, this is 26 point, center, 2265. See, 2265. Almost same, slightly lesser. And then, if I draw tangent here, the slope here is clockwise of theta A 0.2752 degrees. 0.2752 degrees. If I draw tangent here, slope is anti-clockwise of theta B. Where is it? 0.3805 degrees. 3805 degrees. And then, see, then here, if I draw a tangent here, slope will be lesser. You write the answer here. Slope at C, 0.2752. If I draw tangent here, slope is anti-clockwise. This slope is what? If slope is clockwise here, anti-clockwise, you write whatever slope you got at D, 0.1138. And at center, very small slope, because why? At very small slope of How much? 0.0155 degree anti-clockwise. This is the elastic curve. Because difficult right to scale, make a note. Now, when you go to ETAP, you type distance equal to 3 meter, you get this deflection. Type distance equal to 7 meter, you get this deflection. Distance equal to 6 meter, you will get how much center deflection? 26.2265. And if you substitute distance equal to 5.84365, or if you ask it to give y maximum, it will give almost equal to center only. Because why? That 0.02, nobody will bother for design part. Now, clear now? All the deformation. Clear means tell me. I will rub and go to fresh part now. If fully clear, I will rub it. 26. Oh, print mistake. Okay. 26 point. Print mistake. I told you, only chance of mistake. 20. Otherwise, nonsense. Why? When this is 26, how it can be 24? Print mistake. Change it. I saw there. See, 26 only is there. When I looked there, the 24 I saw. Okay. I told print mistake. Don't make issue of print mistake. Correct now? Print mistake, don't bother. Print mistake. Some will tell, if sir make the mistake, he will tell print mistake. If we make the mistake, he will highlight it. Yes, you should not make mistake. I can make mistake, oversight, I will correct it. Now, fully clear? Tell me, fully clear? I will rub this one now. This type of sketch I won't give again and again. 0.4173, yeah? Oh, yes. Okay. Again, one more print mistake. 0.4173. Maximum slope. See, print mistake. 0.4173 degrees. Okay. And remember, ETAP, deflection is along global Z, whereas rotation is about global Y. Or local, if you tell, deflection is along local 2, rotation is about local what? Local 3, if you want local global information. Full clear means I will rub it now. Okay. Now, that's all. That's all required for ETAP batch. Now, if you are live, okay, or continuation is your choice. From ETAP point of view, nothing more required. Okay. Start. Now, very, very important. See, make a note. As I rub the board here, I will dictate something. What all I see, for I can do two things at a time. I can rub the board and talk, no problem. Words will come to me. See, keep on writing. So far we considered loading either only point loads, only point load. If only point loads are there, there is no problem. Take any one end origin, take a section between the last 2 points on the other side, write the BM equation, and then happily solve. Write everything, those who are interested. Next we considered UDL, and we considered UDL for full span. Therefore, if the UDL is for full span, there is no problem. Happily you can take section XX and you get the answer. Now, consider partial UDL. See, consider partial UDL. Partial UDL. Partial UDL can be two different types. See here. Partial UDL. Make all the notes. Partial UDL can be three different ways. See, either this way, see, or this way, or this way. See, it can be somewhere here. See, full UDL is here, already over. Full UDL is here, already over. This is full span UDL. Span UDL, already over. We are discussing partial UDL. It can start from here and go up to here. See, I will take A here, B here, and C here. AB is not required. Okay, now. Or it can be that side. Or it can be the middle portion. Now, there is a problem. Note, in Macaulay's method, point number 1, right? Point number 1, general point. Origin selected should be always extreme end of the beam. Clear? One by one I am telling now. Make a note. I want to give note here. Origin selected should be extreme end of the beam. 1 point. Everything is compulsory. What I am telling now for requirement for Macaulay's method, everything should be satisfied. First, point number 1 or requirement number 1. This should be satisfied. Origin selected should be extreme end of the beam. Clear or not? Later, if you don't write, you are in trouble. Clear? Okay. Second one. See, I will give second point. Second point. Section XX should be between the last two standard point on the other side at X from origin. Section XX should be between the last 2 points. If the left hand is origin, it should be last or the right side, between the two standard point there. Or if right hand is origin, it should be between the last 2 points on the left side. Tell me, second point also clear? First, second point also clear? I don't know, it's a word clear. Second point also clear. Won't repeat once again. Yes. Next, constant of integration, I always write first. Okay, that you know it. Right, third point. He in his class, he writes constant in the first because it is valid everywhere. Fourth point. When you integrate, next point. When you write expression for bending moment, you write in correct order starting from origin. Okay. Fourth point. Fifth point, not randomly. Fifth point. Fifth point. In case of UDL or UVL, I will tell little later. Little later. The fifth point, I will tell little later. Little later. That is in case of UDL or UVL. Little later I will tell you. Okay. Sixth point, continue. This I will tell you. Continue. When you integrate a term that is x minus a, do not integrate as x square by 2 minus ax. This is wrong. Integrate as x minus a whole square by 2 or bracket term should not be disturbed. Clear? Yes or not? Okay, do one thing. You make this as point number 5, this only. Fifth and sixth I will tell later. Okay, leave it. No, that one leave it now. You make this as point number 5. Clear? Integration of x minus a should be x minus a whole square by 2 or not x square by 2 minus ax. Brackets should not be broken. Okay. Then, sixth point. When you substitute the value of x for any reason, either in the slope equation or deflection equation or in the BM equation. BM you are not doing. See, long back I told BM equation. Then you should not consider those terms due to which BM will come on the further side, or non-applicable terms should not be considered. See, for example, if there is a point load here, if I take a section XX, if I take a section XX here at x from here, after this point load will come. If I use the section for here, if I use x from here, this point load will not come. That I told very clearly, I will not explain now. Non-applicable terms should not be considered. Or easy method, I told you. What? Easy method. To eliminate or not to skip non-applicable term, never consider the term for which inside bracket the value becomes negative when you substitute the value of any x. When you substitute the value of x, if any term inside the bracket. See, x minus a. If x minus a is there, it is valid only after what? X is more than a. If x minus a is, or you can write, if x minus a is there, this term is not to be considered if x is less than a. That is the correct answer. This is all I explained. Or you can remember, when you substitute the value of x, any x, if a term, for a term inside the bracket, if you get negative answer, negative value, that term should not be considered. Where brackets are not there, no problem. See, where brackets are not there, it is valid for the entire beam. Where brackets are there, you should not consider the term x minus a if it gives negative inside the bracket for that value of x. Tell me. I won't repeat. This is also clear. Last point. This is also clear. Next. In case of UDL. Next point. What is the point number? I forgot. Next point. You write point number yourself. Next point or next requirement. Required. Compulsory. Compulsory. In case of see, you write here. In case of UDL or UVL, section XX, see, section XX should pass section XX at x from origin. X from origin should pass through UDL or UVL. Clear? Compulsory. In case of UDL or UVL, section XX at x from origin should compulsorily pass through the UDL or UVL. Clear point? First, it has to pass. I will explain what is the reason. Okay. If UDL or UVL is there, section XX should compulsorily pass through the UDL. Clear? It is compulsory. Clear? Okay, now make a note. Suppose it is this question. See, I will put 3 examples here. Example 1, example 2, example 3. See here. Remember, one more note. Section origin should be always extreme end. That is compulsory. See, question number 1. If I take this is A and B. See, if I take AB, and this point is C, other loads are not there. Okay. Imagine only this much. Okay, start. Here, make a note. If I take A origin, section XX should be between here. If I take A origin here, see, C, A, B, C, B. If I take A origin, section XX should be between the last 2 points on the other side. Tell me, will it pass through UDL then? Tell the answer. Will it pass through UDL? You write this, everything you are right. If I take section XX at x from A, first important, UDL, UVL later, origin should be extreme end. Second, if I take left origin, section should be last 2 points on the other side. So, if I take A origin, first important, section XX should be between C and B. But it should also pass through UDL. Is it passing through UDL? Tell me. No. Right. This is no. It is not passing through UDL. Therefore, wrong. You cannot take A origin as it is. Or, right here. Suppose for this question, this is A, this is B, this is a UDL, this is C. If I take B origin, section XX should be between the last 2 points on the other side at x from here. Now, will it pass through UDL? First, tell me. If I take B origin, section XX should be this side. Will it pass through UDL? Is it passing through? Yes. Yes. Right. Yes. It is passing through UDL. Therefore, okay. Fully clear? Therefore, okay. Therefore, for this question, you better take B origin. Therefore, for this question number 1, best option is B origin. Same argument here. See, here, if I take a, see, this is C and B UDL here. If I take A origin, section XX should be between the last 2 points on the other side. Tell me, is it passing through UDL? First, tell me, is it passing through UDL? Answer, yes. Yes. Therefore, okay. Okay. But suppose you take BAC. See. Suppose you take B origin, section should be here, between the last 2 points. Now, is it passing through UDL? Answer. If I take B origin, is it passing through UDL? Is it passing through UDL? I will tell you why. 1 minute. I will tell you why. No, it is not passing through UDL. Therefore, wrong. You cannot take B origin under normal case. Okay, start. Therefore, for the second question, best is what? A as origin. Origin. Okay. Come to question number 3. See here. Here, 2 cases I write here. 2 cases I write here. A, B, C, D. A, B, C, D. If I take A origin, section should be between the last 2 points on the other side. Or, if I take B origin, section should be between the last 2 points on the other side. Right? Unfortunately, what? Unfortunately, both these options, both these 2 options are not satisfying the requirement. Yes or no? Here see, A origin, section should be here. No, not passing to UDL. Okay, try. B origin, yes, passes. So B origin is better. Here, A origin, section passes. Okay, done. B origin, it will not fail. So A origin better. But here, A origin, section should be here. B origin, section should be here. Both the options, and origin should be extreme end. You have take always either A or B for this question. So whether you take left hand origin or right hand origin, right here for this question, whether you take left hand origin or right hand origin, both the cases, the requirement of section to pass through UDL is not satisfied. Tell yes or no. Requirement is not satisfied. Tell yes or no. Requirement is not satisfied. You tell yes or no. The requirement of section passing through UDL is not satisfied. Yes. So what to do? I will tell you. Now see. Make a note here. For last I will tell. Question 1, B origin is better. See. I write here once again. Better. Section 2, A origin better. X here. Section 3, there is problem. Now, before solution, how to overcome it, let us discuss why this requirement is there. I think all of you know, someone who is teaching you, they will tell you section XX has to pass through UDL, therefore some adjustment they will make. Yes or no? Tell me. Some adjustment they will make. Say some adjustments are there where you, so that you can see that section passes through UDL. Tell yes or no. Some adjustment is there. Yes, but they will not tell you why it is required. So now, before going further, first, correctly understand why section XX should pass through UDL. Why is that condition? Tell me. Do you want to know or not? What is the reason or why section XX should pass through UDL? Do you want to know it or not? Tell me. If you do not want, okay, you can believe me. See, when I tell it has to pass through UDL, and the reason is there. If people will tell, if it is an academic class, I will not tell. Why? Time is not there. So, and nobody wants to know. Very rare case, 1 or 2 people will come in a full year. Sir, can you please tell why? Personally, I will tell them briefly. So, therefore, let us first understand correctly why this rule is there. Okay, now, for understanding correctly, we will take an example. See, we will take an example, little work for you. You will take an example. See, I will take an example. I will take a simply supported beam, simple, of span 10 meter to avoid what? Changes, 10 meter. This is A, this is B. You consider partial UDL. Okay. Say UDL of intensity some 60 kilonewton per meter. Running for a length of, see, this is 3 and 4, better. 3 and 2, 25, 5 better. Okay, or I'll do one thing. Beam of span 12 meter. Okay, 12 meter. UDL for a length of 7 meter. UDL of 60 kN per meter for 7 meter. It will be 5. This side gap is 3 meter. That side gap is 2 meter. Tally aita? Yes. So the question is, this I will call point D, C and D. This is a demo example, C and D. So our question is, a simply supported beam of span 12 meter is loaded by UDL of 60 kN per meter for a length of 7 meter. UDL starts at, if you refer left hand, at 3 meter from left hand, or if you refer right hand, UDL starts at 2 from right. See, when they tell 3 from left, this will come 2. Or if you tell 2 from here, this will come 3. Both, anything can be given. Now, using expression for mx, using general expression for Bm at xx, Bm at xx, that is called mx. Mx, find bending moment at A, B, C, D, A, B, C, D, and also at 3 points P1, P2 and P3. P1 is at 2 meter from A. P2 is at 3 plus another 4. 3 plus another 3. 3 plus 2. B2 is at 5 meter. This is at 5 meter. 8 meter. 8 agate. 8 andre? Okay. 5 meter from where? From A. From A. And P3 is at anything, somewhere here. 1.5 meter from B. Or I will tell this one now. Start. Now first what you do is, first forget double integration or Macaulays method. Why? Because these are used to find slope and deflection. Clear? The double integration method or Macaulays method are used to find slope and deflection. Here question is not slope and deflection. Here question is bending moment. But here, therefore, go to basics and do not consider equation. Do not consider that section XX all. No section XX. Simply find bending moment at all those points. Then I will tell you, take section XX and check the answer. Then you realize what, see, even if you are finding slope and deflection, before that you require equation for BM. Long back I explained, if BM equation is valid, theta equation valid, and also deflection equation is valid. If BM equation is not valid, theta not valid, and also y not valid. So for equation for theta and y to be valid, BM equation should also be valid. Yes or no? Tell me. Because you equate EI d square y by dx square equal to mx. So if you want theta and y equation to be valid everywhere, then BM equation also should be valid everywhere. Tell yes or no? Because why? Even for slope and deflection, first step is BM only. Tell me yes or no? Tell me yes or no? What? Yes. Okay. Now, what you have to do now is, see, what you have to do now is, first, see, consider the beam here. I will do one thing now. I will write here, the beam, I will write somewhere here. First, you find support reaction. First, find support reactions. Support reactions VA and VB. Okay, this is A. I'll put it bigger here. 1 minute, little bigger. This will be there up to tomorrow. This will be there. I am not rubbing this one. See, this is A. This is B. This is the reaction VA. This is the reaction VB equal to then 372. 372. Okay. There is a UDL here this way. Out of scale. Okay. Okay. This way. This is 3 meter. This is 7 meter. This is 2 meter. 2 meter. UDL of 60 kilonewton per meter. This is the point C. This is the point D. There are 2 extra points are there. So 3 extra points are there. Extra point, I will use blue color. Extra point, remember, I will use blue color. Make a note. Or I can use red color. Red I am using for section XX. Extra point, I will use blue color. Why? Because extra point, remember. Okay, see. Now, it's already blue color. What to do? Ayyo. Okay. I use black color. Extra point, I use. Okay, I use red color only. Red color. Okay. That red is not section XX red. See, 1 extra point is at 2 meters from A. Light line here. See, this red is to identify that it is extra. It is the point P1. Somewhere here mark. This is 2 meter. 2 meter. Next extra point is P2. Where is P2? At 5 meters from A. 5 meters from A means your P2 is here. See, your P2 is here. From here 5 meter. From here 5 meter means anybody can tell me what is this distance from here. If this is from here 5 meter means tell how much from here first. How much from here first? Two meter. This is also 2 meter. This not 5 meter. Change the question. I do not want same number. Not 5 meter. I will take 5.5 meter. Okay. I will change it to 5.5 meter. Tell the answer here. 5.5 here means how much this one? I do not want same number. 5.5 meter from A. Question changed. Question changed to 5.5 meter from A. Then from the nearest point here, how much? 2.5 meter. I do not want same number. 2.5 meter. This is your point P1. This is the point P2. P3 is somewhere here. See, nodi. P3 here. Unknown point. That P3 point from right end is at 1.5 meter. This is the point P3. First tell me, what is the reaction VA? What is the reaction VB? First VA. Take moment about A. Minus VB into 12 plus 60 into 7 is the total load into 3 plus 7 by 2 equal to 0. If you do not know how to find VB, VA, VB, better not attend my class. Minus VB into 12 plus 60 into 7 is the total load into 3 plus half of 7 equal to 0. VB, don't give wrong value. 192.5. Your VB will come 192.5 kilonewton. Sigma V0 upward positive plus VA plus VB minus 60 into 7 equal to 0. Tell VA value. Tell VA value. 227 point. 2 VB 192, VA 227. VB should come more than VA. What is this one? Why? Load is more that side. Impossible. Oh, see. You should, when I ask VB, you should tell VB value. VB is 227.5 kilonewton. I got that much common sense. VA is 192.5 kilonewton. Anybody, if the reaction is not clear, better not attend any of my class. No, you cannot come to my class if you cannot find reaction. No. Anyway, not that I don't believe you. Uh, 227.5 and 192.5. Now see correctly. Now, this is a beam. Do one thing. See, this will take little time. You told you want to understand. So now, do one thing. Write a note here. Never bother about double integration or Macaulays method. Imagine you are in SFD and BMD chapter, where you are asked to find bending moment at A, then B, C, D, and also P1, P2 and P3. Therefore, correctly answer. See, I want all sagging positive. I want bending moment at A, 100% 0. I want bending moment, you do in correct order. You write here, start. Bending moment at A, see, look this side, 0. Bending moment at B, look that side, at B, 0. Then write. You show the calculation. Bending moment at C, see, I write here now, C point. This over now, I write below C. Bending moment at C equal to, look this side, 192.5 into 3 positive. Tell the answer. Plus 192.5 into 3. I will not show the calculation. I have got better works to do. 1 minute. That way. Then also tell me what is the bending moment at D. Look that side. 227.5 into 2. After this is over, then between these two, point P1 is here. Between these two, point P2 is here. Between these two, point P3 here. Now calculate what is the BM at P1, what is the BM at P2, what is the BM at P3. See, BM at P1, look this side, 192.5 into 2 over. BM at P3, look that side, 220 P3 plus 227.5 into 1.5. BM at P2 plus 192.5 into, this is 3, this is 2.5, 5.5 minus 60 into 2.5 into 2.5 by 2. All this value I want in kilonewton meter. In kilonewton meter. All this value I want in kilonewton meter. Okay, now do one thing. I'll take just 5 minutes break. Take a rough sheet and find all the bending moment. Can you find? Then I will tell you what is the problem. Then I will tell you what is the problem. Can you get it now? If tell me, I want 5 minutes break. If you can get it, can you get it? Comment yes. If you tell yes means, I will come after 5 minutes and write all the values as you tell. Okay, start. I will tell you the reason. Somebody may ask you, sir, why it has to pass through UDL? I am justifying it. You can make out now You can tell anybody. If you tell, no, it is a rule. Why rule? No, people do that way. Don't tell people do that way. You tell the reason. But if you talk that way in the colleges, you'll be thrown outside. Be careful. You'll be thrown outside then. Okay, enough. You got all the values? Fast. All the values came? Okay. I will write whatever you got. 1 minute. Where is the pen I kept? I don't know where I kept it. It was having in hand. Then somewhere I misplaced it. Okay. See. Usual problem of misplacing. Then searching for it. Where is it? Where is it? Okay. I will write all the values. Whatever you tell, I will write. Then I will check it. Anybody who is not able to get means not fit for any subject study from me. BMX. I will use the color, same color. Black I will not use. Okay. Use the blue color first. Right. Okay, got it. BM at P1, BM at C. C is plus 550. Oh, it's a black color. 1 minute. Okay. Plus 557.5 kilonewton meter. BM at D plus 455. Okay. 455. Then BM at P1, P2, P3. Red color I want. Those BMs I want red color. Why? Extra point. Remember, red is not section XX red actually. I want red color. This red will vanish later. BM at P1 plus red. Coloring is, I should maintain the same color cap. Plus 385 kilonewton meter. BM at P2. BM at P2 plus 871.25 kilonewton meter. BM at P3 plus 341.25 kilonewton meter. Remember, these are all by basic. All by basic. Therefore, all these are correct. Clear now? All these are correct. Tell yes or no. These are all by basic. You got the answer, and check it now. Therefore, these are by basic concept. Therefore, sorry. Mic. Sometimes it happens. I forget the mic. All these we got by basic concept. So, everything is correct. Nobody can dispute. Section XX all comfort. Clear? Okay. Now do one thing. Right. Now, you write a note. Correctly write a note. See, I need some space here. I will remove this one. Make a note. What all I tell, make a note. Then only you will understand. Not by simply attending the class. See, now, these are, but right, this side is full basic concept. So, perfectly correct. Okay, now start. Now, you write here. Now, I write black color. Now, see, that is that combination of blue and red. That is basic. Now, you imagine that this question is required for slope and deflection calculation by Macaulays method. You should write what I am dictating by Macaulays method. In the Macaulays method, you have to take a origin at the extreme end. Any extreme end will do. At extreme end and take a section between the last 2 points on the other side. Therefore, I will write here, first consider now and write equation for mx. If that mx equation is perfect, if you substitute in that mx equation, if you get the same dm's, then you can integrate twice that mx equation and get equation for slope and deflection. Clear now? Now you go to Macaulays method, select a origin, take a section between the last 2 points, write equation for mx. Then using that equation, find bending moment at all these points. If bending moment at all the points are tallying, then that mx equation can be used to continue the question for further, that is integration. It is ready for integration. Clear or not? Fast. See, if that equation is wrong, you cannot go for slope and deflection. Clear or not? If the equation is correct, then you can proceed further. Yes, okay. Now start. Right here. Now, let us now do one thing right here. Now you are going to slope and deflection calculation, for which first step is mx. Okay, start. Consider left extreme end A as origin. Okay. And consider, see, A as origin, red color. This is the red color, not that red color. And consider, I should have used there black and blue. I should not have used red there. That red is not this red. And consider section XX between last 2 standard points. Tell me, last 2 standard points. Which one? Tell me fast. Last 2 standard points. Which one? If A is the origin, last 2 standard points. Which one? Fast. Don't see this one. Last 2 standard points. Which one? Last 2 standard points. Which one? Fast. If I take A origin between the last 2 standard points. Which one? This much time. That is D and B. D and B, okay, mix of color. D and B at X from origin A. Okay, start. Write a neat sketch here. See. Any color will do. Once you understand thoroughly, then there is nothing here. This is reaction VA equal to 192.5 kilonewton. This is reaction VB equal to 227.5 kilonewton. Then there is a, see, now you should stick to the Macaulays method now. 3 meter, don't write dimensions here. See, you first mark the UDL. UDL stops here. How much UDL? See, UDL here. This is 60 kilonewton per meter. This is A, this is B, this is C, this is D. We are taking A origin. X is going this way. If you take X between the last 2 points here, these are all the requirement, XX, at X from here. X here. Now, come down and mark everything with respect to origin. Now you follow Macaulays method. Tell fast distances. First, tell the T distances I have to consider. First, see the problem and tell me. Okay, why I ask you? This is 3 meter, this is 10 meter, this is 12 meter. Tell yes or no. I want answer, yes or no. 3, 10 and 12. Tell me yes or no. 3, 10 and 12, systematic way marking from where? Left hand origin. Yes. Okay. Now, write equation for bending moment at XX. That is called MX. M at X. With A origin, sagging positive. See correctly what I am doing. Sagging equal to, start here. Plus 192.5 into X. Plus 192.5 into X. Then minus, see correctly, minus 60 kilonewton per meter for what length you cannot see there. See correctly, that length you cannot see here. See, you can do one thing, somewhere upper side mark the length of UDL. That you are not doing next time. Somewhere here I want systematic, 7 meter. Tell the answer. 60 into 7 is the total load. Tell yes or no. See, plus 192.5 into X minus 60, you can see the full UDL. 60 kilonewton per meter for 7 meter into bracket, this is X minus, tell how much? X minus, see bending moment here. 60 into 7 is the total load into center of the load from here is X minus 3, X minus 3 and also minus how much? X minus 3 and also minus. See, center of the UDL is acting here. So the total load is acting here into this distance. It is X, this from some center to here is X minus 3 and also minus 7 by 2. Also minus 7 by 2. Or you can write once again. Write once again. You first write this one, then write second time. BM at XX is, instead of this way, you write 3 and 7.5. Clear now? I explained for you how 7.5. You first time write X minus 3 minus half of 7. Then second time write, finalize the answer. It is X minus 7.5. Tell yes or no, fast. You just tell me yes or no, that's all. Then time problem is there, okay. You tell me correctly, yes or no. Clear means yes. You are not commenting. Clear, okay. 6.5. Oh, sorry. Print mistake, 6.5. Okay. 6.5. Oh, 3.5 plus 3 is 6.5. Okay, now write. Now, note. You write here. You write here correctly. For finding bending moment anywhere, substitute the value of x. Value of x from origin A. From origin A. And do not consider what? Do not consider terms which are not applicable. Which are not applicable. Or in crude method or simple method, what you can tell? Do not consider terms. Do not consider terms which will result in negative value inside bracket for that value of x. That value of x. This I told you 1,000 times. Clear or not? Now use this equation and find Bm. Do not consider the terms which will give negative sign inside the bracket. Clear or not? Fast. Clear or not? Fast, tell me. Is it clear or not? This expression. This you know it? Yes. Okay, start. Now, to find bending moment at A, I want to find bending moment at A. Tell me. Substitute x equal to, fast answer. Substitute x equal to, fast. To find bending moment A, substitute x equal to, fast. Time is not there. Substitute x equal to find bending moment at A, substitute x equal to, you are wasting time. Today I want to finish this one now. X equal to 0. Start. 0. Then Bm at A, MA sagging equal to, start. This is 192.5 into 0 over. Remember, stop. Why stop? X equal to 0 means 0 minus 6.5 will give negative inside the bracket. Do not consider this term. So answer is tallying. Tell me, yes or no? Answer is tallying. Fast. You just tell me yes or no. This term is not to be considered. Why? 0 minus 6.5. So answer is tallying. Tell me yes or no. I want tallying or not. Yes. Okay, start. Then to find bending moment at C, how much? Substitute x equal to, fast, tell me. Substitute x equal to, fast. Don't waste time now. So trap is there, don't worry. Trap will be always there. There will be trap. X equal to 3 meter. Start. Therefore, bending moment at C sagging equal to, start, plus 192.5 into 3 minus 0. I don't know. Then stop. Why stop? When you put x equal to 3 meter, 3 minus 6.5 will give negative inside the bracket. This term is not to be considered. Therefore, answer fast. I will clarify everything, don't worry. When I take a subject and start something, I know correctly how to complete. Don't bother. These are all nothing for me. Tell me answer. Tell me answer fast. See, when you put x equal to 3 minus, you should write it. You should make a note here. 3 minus 6.5 will give negative inside the bracket, not to be considered. Stop. Tell me answer. You are wasting time. Trap plus 577.5. Plus 577.5. Oh, this also is tallying. Yes or no? This also is tallying. Tell me yes or no. Correctly tallying. You just tell yes or no. Tallying. See, tomorrow when I continue, first I'll give a warning. My today's class is continuation is meant only for those who attended yesterday's class or those who studied yesterday's class. Otherwise, leave, don't come. Okay. Now, to get bending moment at D, substitute x equal to, how much, tell me? To get bending moment at D, substitute x equal to, answer. To get bending moment at D, substitute x equal to, fast. X equal to, you are wasting time, 10 meter. Okay, 10 meter. Therefore, bending moment at D equal to plus 192.5 into 10 minus, see, 10 minus 6.5 is positive inside the bracket. Therefore, to be considered, right? So, right here, when you put x equal 10, this term is positive, minus 60 into 7 into bracket, how much? 10 minus 6.5 is plus 3.5. Positive came. Therefore, to be considered. Answer. Little more time will take the class so that it will come to a stage today. I do not want to waste time tomorrow. Once again telling. I don't want to waste time tomorrow. I should come to a stage now. Plus 455. 455 kilonewton meter. Oh, that also is tallying. Then I want bending moment at B. Substitute x equal to, answer. Substitute x equal to, fast. I want bending moment at D. Substitute x equal to 12 meter. So bending moment at B equal to plus 192.5 into 12 minus 60 into 7 into 12 minus 6.5 is plus 5.5. That also correct. Positive inside the bracket. Answer 0. Oh, that also is tallying. Now, come to 3 other points. Okay, I'll do one thing here. Okay, come to 3 other points. Then, to get bending moment at P1. Tell me fast. Substitute x equal to, answer. Substitute x equal to, don't waste time now. Time already over. I want to finish today. Substitute x equal to get bending moment at P1, substitute x equal to 2 meter. Okay, start. 2 meter. Therefore, bending moment at M at P1 sufficient. M at P1 equal to plus 192.5 into 2. Stop. Why stop? When x is 2 meter, 2 minus 6.5 will give negative inside the bracket. So this term is not to be considered. Answer. Why you are wasting time? It is plus 385. Oh, this also tallying. Then to get bending moment at P3, P2 last. P2 last. Tell why? Tell me. P2 last. Some will ask, sir, after P1, P2, no. P2 special. So P3, tell the answer. Substitute x equal to get bending moment at P3 from here. Substitute x equal to, fast. Substitute x equal to x from A. Substitute x equal 10.5 meter. 10.5 meter. Therefore, bending moment at P3, I am skipping P2 equal to plus 195.2 into 10.5 minus 60 into 7 is the term into bracket. 10.5 minus 6.5 is positive inside the bracket into plus 4. Answer. Past, tell me answer. Over. One more line. Today's class over. Then you think what to do. Actually, some of you knowing it answering. Some of you will be already knowing. But if you know it, don't message in the class. Why? Others I want to ask. Tomorrow, I want to ask others. So, some of you will be knowing. If knowing, you can message me personally. Don't message in the group. If you message in the group, others will be knowing the answer. If you know the answer, message me in the personally message. Don't message in the group. Answer. Same. So, P3 is plus 341.25. This also tallying. Now, lastly, bending moment at P2. That is special point which lies somewhere inside what? Tell me. The P2, see, A tallied, B tallied, C tallied, D tallied, P1 tallied, P3 tallied. No problem, everywhere tallied. Whereas the P3 point lies somewhere in what? It lies right there. The P3 point right here, P2 lies somewhere within the UDL. Okay, start. Tell me, substitute x equal to, fast answer. To get BM at P2, substitute x equal to 5.5 meter. Substitute x equal to 5.5 meter. When you substitute x equal to 5.5 meter, and do one thing, not only P2, I want one more point P4. One more point P4 is there, which is at, from here, from right side, little more, 2 Allah, from right side, 3.6 meter from B. I want one more point P4 right here. One more point P4 somewhere here I want. P4 at how much distance? How much distance here? 3.6 meter from here. Tell me now, from basic calculation, what is the BM at P4? Tell the answer. Start. From basic calculation, plus 227.5 into 3.6 minus, if this is 3.6, this is 2, this is 1.6. It is plus 227.5 into 3.6 minus 60 into, see, if I write here, if you want I write here, equal to basic calculation, plus 227.5 into 3.6 minus 60 into, this is 2, this is 3.6 into 1.6 into 1.6 by 2. Tell that bending moment. Correct, basic, not here, basic calculation. Add one extra point, bending moment there. P4 bending moment. P4 bending moment. One more point, P4 is there. 7,000. What is this? How it is possible? 7,000. How 7,000 will come? Where you are 742.2. Okay, it is 742.2. Okay, now extra. Start here. When we put x equal to 5.5 meter, then BM at P2 equal to, this is the special point, plus 192.5 into 5.5. Stop. Why stop? Tell me. Why stop here? When you put x equal to 5.5 meter, why stop here? See, 192.5 into how much? 5.5. Why stop here? Reason. Why stop? Why stop? Reason. Why stop? When I put x equal to 5.5 meter, I told stop. Why stop? You are not giving answer. Why stop it? It gives negative inside bracket. Tell the answer. How much answer? 192.5 into 5.5. What is the answer? Answer. 19. You are not telling the answer. You are telling correct answer. Tell the answer. If you substitute here, 192.5 into 5.5. 1058.75. Oh, this is not tallying. Yes or no? This is not tallying. Not tallying with the correct answer. Correct answer is 871.25. Correct answer. It is not tallying. Tell yes or no? Not tallying. Also, one more point, right? Also, that extra point P4. Tell the answer. Substitute x equal to. Tell the answer. Extra point P4. Substitute x equal to. P4 is at 3.6 from here. How much x from A I should substitute? Over. Today's class over. 8.4 meter. Substitute x equal to 8.4 meter. Then bending moment at P4 equal to plus 192.5 into 8.4 minus 60 into 7 is the total into 8.4 minus 6.5 is what? Plus 1.9. See, when you put 8.4 here, this is positive, therefore to be considered. Answer. It is to be considered. Why? When x minus 6.5 is there, it is considered for any value of x more than 6.5. Answer. Over. Today's last answer from you. 819. 819. It is plus 819. Whereas the correct answer is how much? 742.2. Therefore, this also is not tallying. Or conclusion, right here. Conclusion. Bending moment will tally at all the standard points. And if the point lies where UDL is not there, it tallies. See, it tallied at A, at B, at C, at D. P1, P3, it tallied. But it will not tally with the correct answer if the point lies somewhere inside the UDL. So, our equation will not give correct answer if you consider a point which is somewhere in the UDL. Yes or no? Which is somewhere in the UDL, it will not give correct answer. It will give wrong answer. Tell me yes or no. It will give wrong answer for those points which lie somewhere inside the UDL. Yes. Therefore, what to do? Tomorrow I will tell what to do. Tomorrow I won't waste time with B origin. You can try yourself only. Or briefly I will tell you B origin tomorrow. Or in the board, write, and I cannot write because this all I require it. Or I may write it also. Okay. If you think now what to do. Tomorrow, if you know the answer, don't message in the group. Why? Those who are not knowing should not know it. I will tell them. If you know the answer, message me personally. Otherwise, see, today I have no sleep. Why? I am in full tension now. What to do? What to do for tomorrow? I have to study thoroughly today night, full night. So if you can help me by giving solution in the person. Don't make public. Personally, you tell me the answer so that I can sleep peacefully today. Otherwise, I will be in terrible tension. Okay. Terrible tension means, why should I start all this one? Okay, leave it now. Okay. Message me personally. Don't message in the group. Those who are in the BSK batch. General public, they can message in the message box if you want. Nothing serious. Tomorrow I will make fully clear. Don't worry. Today I thought I will make it now. But now time is not there. I will tell what to do, how to overcome this difficulty when the point lies within the UDL, so that we will write a MX equation which is valid even for the inside points also. Which is valid even for the points which are inside. If I write that one and get it correct, then I can go further for slope and deflection. Okay. Tomorrow we'll meet. Thank you. Okay.